Hey guys, this is Calvin from InstaLOD. In this video, we're going to take a look at the automatic interior occlusion culling mode. Please make sure to watch part 1 of this video series so that you're up to date with all of the occlusion cull settings and know what they all do. In this example, I have a simple scene composed of two spheres, of which one is within the other. The outer sphere has a hole in it, exposing some of the polygons of the blue sphere. For our first scenario, I want to remove all of the polygons from the blue sphere that we can't see. To do this, we will select the bi-polygon mode in the culling strategy and make sure that Remove Geometry is enabled. In this scene, we can reduce the resolution to 256 to speed up the overall process. Remember, the higher the resolution, the slower the occlusion cull. However, going down too low with the resolution can result in holes, which, however, we can fix by using an adjacency depth. For our first example, I will keep the adjacency depth on 0 and click Start. In the resulting scene, we can see how the hidden polygons of the blue sphere have now all been removed, keeping only those polygons that are visible to us. Let's go ahead and try out some other settings. Let's say that I don't want to remove any polygons. I just want to make sure that the sphere on the inside gets some optimizer weights applied to it, so that I can optimize it independently from the outer sphere. This process can be done manually in a simple scene like this by using the filter selection. However, this would become quite a tedious task in larger scenes with increasing complexity. Therefore, this is a great way to automate such a process. First, we will change the culling strategy to by submesh and change the data usage to write as optimizer weights. Next, we need to determine the polygon threshold. From our previous process, I know that around 49 polygons are visible to InstaLOD using the current settings. Therefore, I will specify a threshold of 55 polygons to have a bit of a buffer, so that I can be sure to match the internal blue sphere. With this done, I can determine the optimizer weight that I want to apply to the mesh. This could be a positive value, which will result in a blue vertex color that would maintain these polygons, or a negative value, which would result in a red vertex color being applied, which would reduce the polygons. I will keep the default value of -80, which will give the mesh a red color channel value of 80%. If we go into the vertex colors render mode, we can see that this worked beautifully. Now I can use the optimizer, specify the color set in the optimizer weights, and optimize. Here we can now see how only the internal model with the optimizer weights has been reduced. Let's go ahead and apply these principles to some more complex scenes. First off, I have this motor with loads of internal parts, screws, gears, and so on. To remove the interior, I'm going to select by polygon, set the resolution to 512, keep the adjacency depth on 0, and click Start. From 700,000 polygons, we have removed 500,000 polygons without losing any visual quality. That's the beauty of occlusion culling. We are optimizing this scene drastically without losing any visual quality in our meshes. For the next example, we have this vehicle, which we will only be looking into from the exterior. Therefore, I would like the interior to have less detail than the external chassis. To do this, we will use the by submesh mode. Write optimizer weights, use a threshold of 50 polygons, and keep the rest on their default settings. Here we can see that this worked just fine, so we can now move on to optimizing the scene. Just make sure to select the correct optimizer weights. I will add a second mesh operation entry with a 50% optimization as a reference point to compare the difference between a standard optimization and using our custom generated optimizer weights. And there we go. We can see that we have managed to only optimize the interior and keep the exterior intact. Whereas with the standard optimization, the exterior has lost some quality due to being reduced, while not removing as many polygons on the interior as we might have wanted. I hope this video was able to give you a good overview of what is possible with automatic occlusion culling. In the next video, we will take a look at the camera-based mode.